Hello viewer, welcome to another aspect of today teaching. Today we want to discuss types of motion. Now before I continue, I want to use this opportunity to thank those persons that are following me up on Facebook and also on YouTube channel. On my YouTube channel, I want to use this opportunity to appreciate your determination and your doggedness. God will bless you. And please keep the spirit high, keep the spirit high, keep the spirit high. But now I want to look at another aspect of motion today, and this one will be on the types of motion. We want to analyze them one after the other. We have rotary motion, we have vibratory or oscillatory motion, we have another one which is translational or linear motion, and we have another one again, random motion, and the last one there is relative motion. But we just discuss four. We are going to discuss four today. We are going to discuss just four today. And for the calculation, for the area of calculation, we will just discuss two, and we are going to discuss two on the area of calculation, which is number one and number two, the rotary motion and vibratory motion. We are going to discuss on that when our time progresses. When we want to look at the area of calculation, we are going to focus our mind on that two aspects, number one and number two. And there is no calculation in number three, there is no calculation in number four, and there is no calculation in number five. Okay, let us discuss 1 to 4 because of time. Let us discuss 1 to 4. Now we have the first one, which is the rotary motion. We also said that this one can also be called rotational or circular motion. It is also called rotational or circular motion. It is the motion that occurs when an object rotates at a fixed point about its own axis. Example of such motion are motion of a car wheel, that is the movement of a car wheel. That is another example, a clear example under this type of motion. Now another one again is a motion of a planet around the sun. That is another good example of a rotary motion. Another one is electron revolving around the nucleus. While the last one there is rotation of the earth about its axis. We can also have another one. The movement of a ceiling fan. Yes, it's a clear example. And also the rotation of a standing fan is a clear example. Okay, now we can stop there for the rotary. Let us now move on to the second one, which is the vibratory or oscillatory motion. This is also called a periodic motion. It is the motion of a body about its mean position. Example, a charge on a swing is pushed. The swing moves to and fro about its mean position. Right. With this swing, we have it in our various school, and I think our children normally use this to play. When it comes to break, they will sit on it and they will be swinging on it to and fro. Such movement is regarded as what? A vibratory or oscillatory motion. Another example under this type is the string of a guitar when strummed. That when you are playing a guitar, that the movement of the string is a clear example of vibratory or oscillatory motion. Now we also have another one, which is the periodic motion of a simple pendulum, and we are going to look at calculation under this aspect. This simple pendulum, we are going to look at a very simple calculation of this aspect. We are going to calculate on this aspect. That is number 3, simple pendulum. Okay, now we also have another one under this one, this vibratory, though it was not part of the one I gave on the board. It is not part of it, which is the movement of a rocking chair. Is a clear example. Another one is a pendulum clock. The movement of a pendulum clock is a clear example under this vibratory or oscillatory motion. Now, okay, I think we can stop there for that type. Let us now look at the third one. That the third one is the translational or linear motion. This is also called, we said the linear motion is also called translational motion. It is a type of motion in which an object or a body moves from one point to another. That moves from one point to another, and the kind of movement is either on a straight line. This kind of movement is either on a straight line or on a curved path, meaning it can either be done in a straight line or on a curved path. Now, okay, this linear motion, it is divided into two areas, the two aspects. Now, number one there is the rectilinear motion. Rectilinear what? Rectilinear motion, and this kind of motion, the path is straight. Is a straight line. The path is a straight line, while the second one is curvilinear motion. The path of the motion is curved. The path of the motion is curved. Okay, let's now look at example of of an object that undergo this kind of motion. Example of such object. Okay. Now we can just mention. Okay, we can mention the motion of a train. The motion of what? A train. The motion of a train is a clear example of linear motion. When a train is moving on its track, they are moving from one train station to another, is a clear example of linear motion. Another motion we can also have is the motion of a car. Yes, when it moves from one town to another town. Okay, that is another clear example. Another one we can also have under this linear motion is movement of a football. When a player play a football from one goalpost to another goalpost, meaning the movement of that football is a clear example of a linear motion, meaning leaving from one post to another post. Therefore, this is a clear example of a linear motion. Now, while the last one we are going to discuss today is going to be random motion. I remember I told you that we are not going to discuss the 5 because of time. We are just going to discuss 4, and the last one there we want to discuss now is the random motion. Now, the motion of it is the motion of a particle. This one we are talking about now. This random motion. It is the motion of a particle whose direction is difficult to specify. Meaning, what are we saying now? Meaning, it is not definite. The motion of this kind of motion is not definite. It does not have a definite movement. Meaning that is to say now, we cannot really explain the movement of this type of motion. Example of such motion is the movement of smoke in air. The movement of smoke in air is a clear example of random motion. Another clear example is the movement of gas. That the motion of gas in air is a clear example. Another one again is the Brownian motion. But we are not going to discuss on that Brownian motion for today. We are not going to discuss on that Brownian motion. That one is another topic on its own. As time progresses, that is in this subject physics, we are going to discuss on that Brownian motion. It's a topic on its own in physics. We are going to discuss on that Brownian motion. Okay, I think we are okay with this few example of random motion. We are okay with that. Okay, at this point, I'm going to end this class. In my next class, we are going to discuss on number 1 and number 2 because I told you earlier that for the calculation aspect, we are going to focus on just number 1 and number 2, which is the rotary motion and the oscillatory motion. We are going to discuss that one. Under that rotary motion, we are going to look at circular motion. We are going to look at centripetal force and centrifugal force. We are going to look at that. Okay, and also on that number 2, we are going to look at simple pendulum and also a string. That is, we are going to look at spring. Yes, of course, we are going to discuss so much on that aspect, and we are going to do a lot of calculation in that number 1 and number 2. Thank you, my viewer. Thank you for keeping the time with me on this platform to listen to this aspect of today's teaching. I wish you all the best. God will bless you for the time you are keeping with me on this platform. Please try and always join me on my Facebook page, GB Jumbo Online Mathematics, and also on my YouTube channel. Also join me, and that is a mathematics and science mega tutorial. Please don't fail to join me on that two platform, and God will richly bless you for your time. Thank you, and all the best, all the best, all the best.